There is a continent at the southernmost part of the Earth that has remained, for most of human history, unknown and untouched. Covered almost entirely by ice and surrounded by some of the most dangerous oceans in the world, this land was once only an idea, a theory imagined by early geographers who believed that a great southern landmass must exist to balance the continents in the north. Today, that land is known as Antarctica, and although it is now recognized as the fifth largest continent on Earth, much of it remains unexplored. Its environment is unlike any other place on the planet. Temperatures regularly fall far below freezing, winds can reach extreme speeds, and for months at a time, the continent is either in complete darkness or continuous daylight. Long before Antarctica was officially discovered, ancient scholars speculated about its existence. The concept of a southern continent appeared in early Greek philosophy, where thinkers believed in a natural balance of land masses across the globe. This hypothetical land was often referred to as Terra Australis Incognita, meaning the unknown southern land. However, it was not until the age of exploration that sailors began to travel far enough south to encounter the icy waters surrounding Antarctica. Even then, thick sea ice and dangerous conditions prevented most expeditions from reaching the continent itself. It was only in the early 19th century that Antarctica was first sighted. Several expeditions, including those led by Russian and British explorers, reported seeing land beyond the ice. These early sightings marked the beginning of humanity's direct interaction with the continent. As interest in Antarctica grew, so did the desire to explore it. By the late 19th and early 20th centuries, a period often referred to as the heroic age of Antarctic exploration began. During this time, several expeditions set out to study and map the continent, often under extremely difficult conditions. Among the most well-known explorers of this era were Roald Amundsen and Robert Falcon Scott. Both men led expeditions to reach the South Pole, one of the most challenging goals in exploration at the time. Amundsen, representing Norway, carefully planned his journey and used techniques adapted from Arctic exploration, including the use of sled dogs. His expedition successfully reached the South Pole in December 1911. Scott, leading a British expedition, arrived at the South Pole several weeks later. Unfortunately, his return journey proved fatal. Scott and his team faced severe weather conditions, exhaustion, and limited supplies. Their story remains one of the most studied and remembered in the history of exploration. These early expeditions provided valuable information about Antarctica's geography and climate, but they also revealed how difficult it would be to fully explore the continent. As technology advanced in the mid-20th century, scientific interest in Antarctica increased significantly. This led to one of the most important agreements in modern history, the Antarctic Treaty System, signed in 1959. The treaty established Antarctica as a region dedicated to peaceful purposes and scientific research. It prohibited military activity, nuclear testing, and the disposal of radioactive waste. It also set aside territorial disputes, allowing multiple countries to collaborate in studying the continent. Today, several nations operate research stations in Antarctica, where scientists study a wide range of topics, including climate change, geology, biology, and atmospheric science. One of the most important discoveries made through modern research is that Antarctica is not just a flat, icy surface. Beneath the ice lies a complex and varied landscape, including mountains, valleys, and bodies of water. Among these discoveries is Lake Vostok, one of the largest known subglacial lakes in the world. Located beneath several kilometers of ice, this lake has been isolated from the surface for millions of years. The study of Lake Vostok has provided scientists with insights into how life might exist in extreme environments. Samples taken from the ice above the lake have revealed the presence of microbial life, suggesting that organisms can survive even in conditions without sunlight and under immense pressure. In addition to subglacial lakes, Antarctica also contains hidden mountain ranges, such as the Gamburtsev subglacial mountains. These mountains are entirely buried beneath the ice sheet and were only discovered through radar imaging. Their existence has helped scientists better understand the geological history of the continent. Despite these advances, much of Antarctica remains difficult to access. The extreme environment limits the areas where research can be conducted, and logistical challenges make large-scale exploration complex and expensive. Access to Antarctica is also regulated under the Antarctic Treaty System. While tourism is permitted in certain coastal regions, travel is controlled to protect the environment and ensure safety. Visitors must follow strict guidelines, and many areas are restricted to scientific research only. The restrictions placed on Antarctica are primarily intended to preserve its unique ecosystem. Although the continent may appear lifeless at first glance, it supports a variety of organisms, particularly in coastal areas. These include penguins, seals, and various species of birds, as well as microorganisms that inhabit the ice and water. Antarctica also plays a critical role in the Earth's climate system. Its ice sheets reflect a significant portion of the sun's energy back into space, helping to regulate global temperatures. Changes in the Antarctic ice sheet can have widespread effects on sea levels and weather patterns around the world. Scientists study ice cores extracted from deep within the Antarctic ice sheet to learn about the Earth's past climate. These cores contain layers of ice that have accumulated over hundreds of thousands of years, trapping air bubbles that preserve samples of ancient atmospheres. By analyzing these samples, researchers can track changes in greenhouse gas levels and better understand long-term climate trends. Although significant progress has been made in understanding Antarctica, many questions remain. Large portions of the continent have not been directly explored, and the conditions beneath the ice are still not fully understood. The combination of extreme conditions, limited accessibility, and the depth of the ice sheet makes Antarctica one of the most challenging places on Earth to study. As a result, it continues to be an important focus of scientific research and international cooperation. In recent years, technological advancements have improved the ability to study Antarctica. Satellite imaging, remote sensing, and autonomous vehicles have allowed scientists to gather data from previously inaccessible areas. These tools have led to new discoveries and continue to expand our understanding of the continent. However, Antarctica remains unique in that it is governed not by a single nation, but by a shared agreement among many countries. This system of cooperation has allowed research to continue while minimizing conflict and environmental impact. In many ways, Antarctica represents both the limits of human exploration and the potential for future discovery. It is a place where science continues to uncover new information, and where each discovery often leads to further questions. Although it may appear remote and unchanging, Antarctica is an active part of the Earth's system. Its ice, atmosphere, and surrounding oceans all contribute to global processes that affect life far beyond the continent itself. As research continues, Antarctica will likely remain a key area of study for understanding climate change, geological history, and the adaptability of life in extreme environments. In conclusion, Antarctica is not simply a distant, frozen land. It is a continent with a rich history of exploration, a vital role in the Earth's climate, and a landscape that is still being studied and understood. From early theories of a southern land to modern scientific discoveries beneath the ice, Antarctica has continued to capture human curiosity. While much has been learned, much also remains unknown. Its isolation, its environment, and its hidden features make it one of the most important and intriguing places on Earth. And as exploration and research continue, Antarctica will remain a symbol of both what humanity has discovered and what still lies beyond our current understanding. In the decades following the signing of the Antarctic Treaty System, Antarctica gradually transformed into a center for international scientific cooperation. Countries from around the world established research stations across the continent, each contributing to a growing body of knowledge about one of the least understood regions on Earth. These research stations vary in size and purpose. Some are small, seasonal bases that operate only during the Antarctic summer, when temperatures are less severe and access is easier. Others are permanent stations, staffed year-round by scientists and support personnel who endure months of darkness during the winter. Life in these stations is highly structured. Every activity, from scientific experiments to daily routines, must be carefully planned due to the extreme conditions. Supplies are limited, communication with the outside world can be delayed, and emergency assistance is often far away. Despite these challenges, researchers continue to work in Antarctica because of the unique opportunities it offers. One major area of study is glaciology, the science of ice. Antarctica's ice sheets are the largest on Earth, and they contain valuable information about the planet's history. By drilling deep into the ice, scientists extract cores that reveal layers formed over hundreds of thousands of years. Each layer represents a period in time, preserving tiny air bubbles that provide direct evidence of past atmospheric conditions. Through the analysis of these ice cores, researchers have been able to reconstruct Earth's climate history in remarkable detail. They have identified periods of warming and cooling, tracked changes in greenhouse gas concentrations, and gained insights into how natural processes and human activity influence the environment. Another important area of research is astronomy. Certain parts of Antarctica provide ideal conditions for observing space. The cold, dry air and lack of light pollution make it one of the best locations on Earth for studying the universe. Observatories established on the continent have contributed to research on cosmic background radiation and other phenomena, helping scientists better understand the origins of the universe. In addition to ice and space, Antarctica's geology has also attracted significant attention. Beneath the ice sheet lies a complex structure shaped by tectonic activity over millions of years. By studying rock samples and geological formations, scientists can learn more about how the continent formed and how it has changed over time. Evidence suggests that Antarctica was not always covered in ice. Millions of years ago, it was part of a supercontinent known as Gondwana, which also included present-day Africa, South America, Australia, and India. During that time, Antarctica had a much warmer climate and supported plant and animal life. Fossil discoveries on the continent support this idea. Remains of ancient plants and even dinosaur fossils have been found, indicating that Antarctica was once a very different environment. These findings provide valuable information about the Earth's geological and biological history. As the continent gradually drifted southward due to plate tectonics, its climate began to change. Over time, temperatures dropped and ice sheets began to form. Eventually, Antarctica became the frozen landscape we see today. Despite its isolation, Antarctica is closely connected to the rest of the world through ocean currents and atmospheric systems. The Southern Ocean, which surrounds the continent, plays a key role in regulating global climate. It helps distribute heat around the planet and influences weather patterns far beyond the polar region. Changes in Antarctica can therefore have far-reaching effects. For example, the melting of ice sheets contributes to rising sea levels, which can impact coastal communities worldwide. Understanding these processes is essential for predicting future environmental changes. In recent years, scientists have observed shifts in parts of Antarctica's ice system. Some glaciers have been retreating, and sections of ice shelves have broken away. These events are closely monitored, as they may indicate broader trends related to climate change. At the same time, research continues to explore the hidden features beneath the ice. Advances in technology have made it possible to study these areas without direct access. Instruments such as ice-penetrating radar, seismic sensors, and satellite imaging provide detailed information about the structures below the surface. These tools have confirmed the existence of extensive subglacial networks, including rivers and lakes that remain liquid due to pressure and geothermal heat. Among these, Lake Vostok remains one of the most studied, but it is only one part of a much larger system. Scientists are particularly interested in these environments because they offer a rare opportunity to study life in extreme conditions. Microorganisms found in subglacial lakes may have adapted to survive without sunlight, relying instead on chemical energy. Studying these organisms can provide insights into the limits of life on Earth and inform the search for life elsewhere in the solar system. The hidden geography of Antarctica also continues to be an area of active research. The Gamburtsev subglacial mountains, for example, remain one of the most intriguing features beneath the ice. Their origin is still not fully understood, and scientists continue to study how such a large mountain range formed and became buried.